All right, class. So this is a quick review of the cheat sheet I did for today. Okay, so use this and video to help you review for the quiz. So here we have an equation. You're asked to factor it, and so you're going to be asking, how do I approach this? Well, I know it's a trinomial because that's three terms, and I know A is one. Where's my pen? A is 1, right? I know it's not a binomial. Remember, a binomial has two terms. So I know it's not. I'm not going to use the score method or like that on it. So I'm just going to say it's equal to 0. And when I do that, I'm going to minus 28 here, minus 28 on the left side. And that's going to give me x squared plus 3x minus 28 is equal to 0. And when I see that now, I realize I'm going to factor the regular way. It's a trinomial. And so my A is 1. My A is 1. So 1 times 28 is 28. So now I'm going to find the factors of 28. Let me look here. All right. And so factors 28 are 1 and 28, 2 and 14, and 4 and 7. So those are my factors. And so I need to find, I'm going to select which pair am I going to select so that when I add them, right, I get 3, and when I multiply, I get negative 28. And if you notice now, this is the pair I'm going to use. So if I make the 4 negative, when I add, I get positive 3, and when I multiply, I get negative 28. So my factors are going to be, x plus 4, and, x minus 4, and x plus 7, and then 0. Look at the factors. Now they say solve, right? And when you solve for x now, then you set each factor to 0. So my first factor, x minus 4 is equal to 0. And the other one is x plus 7, and that is equal to 0. And I set them. So on the left side, I add 4, that gives me x equals 4. On the right side, minus 7. On both sides of the that gives me x. So that's how you approach that. And on the other side now, I realize this is also a trinomial. If I set it equal to 0 by minus 6 on both sides, that gives me 2x squared plus x minus 6 equal to 0. Trinomial. But now look at this. My A is no longer 1. All right? My A is greater than 1. So I'm going to use the slide and divide method. And so I'm going to take the 2 and multiply the C value. And that gives me negative 12. So I'm going to get I'm writing a new equation now, which is x squared plus x minus 12. See the difference? All right. That's what I'm saying, except on the first problem, our A is 1. So when A is 1 now, I'm right at this part of the problem. I'm right here now. So from here, everything is the same, except when we divide by 2. All right. So my factors of 12. Where are my factors of 12? Let's see. Let me slide this other way. Get out of the way. I need some more space on this side. So my factors of 12. Let's see, put 12 right there. I'm going to have 1 and 12. Oops, that's 12. 1 and 12, 2 and 6, and 3 and 4. All right? So which pair am I going to select so that when I add, so when I add, right? When I add, I get a positive 1, but when I multiply, I get a negative 12. And you can see the pair I'm going to use is this one. If I make the 3 negative, when I add them, I get a positive 1, which is what I'm looking for, 1x. So my factors are going to be x minus 3 and x plus, and that is equal to 0. Now, initially, and this is where this problem is different from this one. Or the first one is I'm going to divide by 2 now. Initially, I multiply by 2, so I'm going to divide by 2 here and divide by 2 here. Now, when I divide by 2 over here, I get a fraction, all right? And so our decimal, so I'm going to multiply the x by 2, and that gives me, 2x minus 3. On the other one over here now, multiplied by 2 is 2, which is an integer, that's what I'm looking for. And so x plus 2. Now let's solve for x now. So those are my factors. To solve for x now, I said each factor is 0. 2x minus 3 is equal to 0, and x plus 2 is equal to 0. Now let's solve for x. I have 3 on both sides, 2x equals 3. Divide by 2, x is equal to 3x. Now this one, minus 2 on both sides, x is equal to negative 2. Very good. And then, let's see what we have here. Now, on this one, this is a binomial. This is a binomial, so I'm thinking, on the first one, if we look at the first one, you notice this is a perfect square, because 4 times 4 is 16, x times x is x squared, and 81 is a perfect square. So when I see that, I know my factor is going to look something like this. All right? One's going to have a plus sign, and the other one a negative sign. So that's your cue right there. So this is the difference of perfect squares. So when I take the square root now of the left side and the square root of the A1, I get 4x here and 9. So I know both factors are going to have 4x and 9. I'm going to have 4x here and a 9, 4x here, and that equals 0. So those are my factors. Now, let's say solve for x, then you got to set each factor to 0, right? So those are the factors, right? On the other one, it is a binomial. Well, look at this now. The left side, this is a perfect square, because 2 times 2 is 4, and x times x squared. Well, 12 is not a perfect square. And plus with a plus sign there. So that is not a difference of perfect squares. So I cannot use this method to solve this one here. So now I'm going to find the GCF. I've got to find the GCF. That's the greatest common factor. So I look at the coefficients. I look at 4 and 12 first and ask myself, what is the highest factor that can go into 4 and 12? Okay? And that is 4. So my GCF is going to start with 4. Then I have x squared and x. And I'm going to ask myself now, what is the highest common factor? If it's x squared and x, then your highest common factor is going to be x. So my GCF now is 4x, this is one of the factors now. My GCF is one of the factors, but I have to find the other factor. Right? And that goes inside the parentheses. To do that, let me get some more space. To do that, I'm going to divide each of these terms by the GCF. So I'm going to divide 4x squared by 4x and 12x by x. Now when I do that, The 4 cancels out. X squared divided by x is just x. Right? I have a plus sign. Let's put the other term down. 12 divided by, see what I do? I do the quotient first. 12 divided by 4 is 3, and then the x cancels out each other. So I'm left with x plus 3, and that is equal to 2. So those are my factors. All right? And then ask to solve now, we just set each of them to 0. All right? So in this case, I would have 4x equals 0, and x plus 3 equals 0. Well, if I divide by 4, I get x equals 0. And then minus 3 on both sides, I get x equals 0. That's if they ask you to solve. Just make sure you know that these are the factors, these are the solution figures. And then lots of examples. I look at here, and this is what we did today. The square root method. All right? And for the square root method, you notice now I have here an x squared. And so if I add 3 to both sides, if I had a plus 3 here and a plus 3 there, that gives me 2x squared is equal to 18. Right? So you see where I'm going with this, all right? I'm going to exclude at both sides. But before I do that, I'm going to divide this by 2, this by 2. That gives me x squared is equal to 9. And then from here now, I take square root at both sides. That gives me x is equal to plus and negative 9. All right? And then the last example, again, square root method, a minus 7 here and a minus 7 there. Here I want to isolate, again, I did express this. I want to isolate my square term. I want to get this by itself first. Then I can apply the square root method. Right? And I didn't mention over here. All right? You want to isolate the square term first. And so I'm minus 7 both sides. This gives me 3 times x minus 5 squared is equal to, what is 3 divided by 7? That's going to give me, I believe, 36, right? Yeah, 36. And now I'm going to divide both sides by 3, divide by 3. That gives me x minus 5 squared is equal to, well, first divide by 3 by 18. That gives me 12. Yeah, 12. Good. I need some more space here. Let's get some more space. That gives me x minus 5 squared is equal to 12. And then from here, I'm going to take the square root of both sides. Because I want to get to my x, but I can't because it's embedded inside a parentheses and square. So I need to cancel the power of 2 square. When I do that now, the x minus 5 is left over, and that is equal to plus and minus 12. Now, this is where a lot of kids struggle on. We've got to try and simplify this. To do that, you've got to find a perfect square that divides in 12 without a decimal or remainder. Remember, a perfect square. A lot of kids they're doing this. They're doing square root of 6 and 2. Well, those are factors. Yeah, 6 times 2 is 12. But neither one is a perfect square. One of these numbers has to be a perfect square. And so if you look at it, it's just going to be 4 and 3. All right, if you're not sure, look at, I'm in our class to list all the perfect squares, right? You got to know these. 1, 4, all right, 9, 16, 25. These are the ones that we use. So the easier ones are, I can go further. These are the ones you gotta know when to use these. So if I divide 12 by 4, that gives me 3. That's why I have 4 there. And then square root of 4 is 2. So I get 2 right over 3. Right? So I'm going to replace now, I'm going to replace 12 with 2 radical 3. So this gives me now x minus 5 is equal to plus and minus 2 radical 3. All right. Now I'm going to have two equations. Now the first one is going to be, let's get some more space here. All right. The first one is going to be x minus 5 is equal to plus the plus sign, the positive answer of 2 radical 3. That's one. And then the other one is going to be x minus 5 is equal to negative 2 radical. And so now I want x by itself to be at 5. At 5. Now, this is not a mistake, but kids are making. They want to say this. They want to say x is equal to 7 radical 3. No, you can't do that. Right? It's not 7. I know you want to combine plus 5. I know you want to combine 5. Yes, you can, but you just can't add the 5 and 2. Remember, it's like an order of operation. Imagine, and I'm going to deviate for a second. Imagine you have 5 plus 2 times, let's use 2 times 3. Okay? If you want to combine those two, you can't just say 5 plus 2, right? Because you have to do the multiplication first, then you add 5. It's the same thing right here. I have 2 times radical 3. All right, so you have to solve this first before you add 5. Well, we're not gonna solve this part right here. We're just gonna leave it the way it is and just write 5 plus 2 radical 3. Yeah, that's what it is. And the other one is gonna be, you have power on both sides, and this means x is equal to 5 minus 2 radical 3. Now, if I'm gonna combine the 5 now, I gotta take the square root of 3. I know we have 1 point something times 2, then I can combine the 5. All right? So that's a quick review, guys, of the cheat sheet. Hopefully that helps. 18 minutes. Ooh, that was very long. All right.